I'm playing an airplane mode, so I can only video one. Okay, like how yesterday's video. Thank you. Okay, now we got an exponential form. Now when we want points for the graph, what would you do? So you'll say x-intercept, let y equal to 0. So this would be 2 to the power 0 is equal to x. X would be equal to 1. Right? That's your 1 value. Your coordinates would be 1 and 0. Then for your y-intercept, you'd let x equal to 0. So you would say 2 to the power y is equal to 0. Now obviously you need to use logs to solve for this, right? But if you use logs to solve for this, you're going to get y is equal to log of 2 and 0. Put that in your calculator. So on the top right hand side, yeah, the top right button, then you put 2 in the small block and 0 in the big block. Undefined. Exactly. Right? Log of 0 would be undefined. So this number is undefined. Okay? Now based on logarithmic graphs, what I showed you before, right? If you go back again to page 136, right? You see where it shows you the graph cuts it at 1 along the x. Like ignore the y-axis part, just the x-axis part, right? You know that your graph is going to look, your x coordinate will be 1 and 0, right? It's going to look either, oh my god, it's going to look either like this, or it's going to look, how it looks? Like this. Right? How do you know which one it's going to look like? Right? Because we do have this coordinate of 1. Right? But now we need to know which one it's going to look like. So what do you do?
Find the gradient.
No. You substitute another value for x into the equation. Right? What that will do, that will give you a point. Now when it gives you that point, you will be able to see where that point is formed. Like if for a value of 2, you get minus 2. Minus 2 will be here. So which graph will it be? It will be the one coming down. If you substitute 2 and you get a value of positive 2, and you see that the positive 2 lies on this point here, your graph is going to fit that curve. Okay, then? Okay, so what you do, just say for example you let x equal to 1. Right? If you let x equal to 1, and you substitute it into it, what's going to happen? You're going to get y equal to 0, so don't choose x equal to 1. Say let x equal to 2. Right? Substitute into this equation here, you're going to say, substitute a value for y. Right? Substitute a value for y. Say let y equal to 1. Right? You say let y equal to 1, it will be 2 to the power 1 is equal to x. And 2 is equal to x. So what coordinate this is? It's going to be 2 and 1. So now when you're drawing the graph, your one coordinate is at 1 and 0. Right? Your other coordinate is at 2. So this will be 1. So this coordinate is at 2 and 1. So when you're drawing your graph, it will look like that. And then this here would be, you can say y is equal to log 2x.
Okay, but if you put it as a negative number, will it change anything?
What?
If you made y negative or something.
Look at the graph, right? Look at this graph here.
Yeah.
Does it cut the x-axis? Oh no, yeah. If you're putting y, it will be if you can put a negative number for y, it will
still come in.
Yeah, because remember, this value here would be somewhere here.
Okay.
If the value came out here, it means that you obviously have to curve this way.
Okay.
If it came on this side of the point, you'll have to curve that way. Yeah.
Okay.
And remember, you can't use negative values for x and stuff because the graph doesn't cut into your negative x-axis. You know what I'm saying?
Okay.
Okay, so you just substitute basically a value for y, you'll get a value for x, and you can draw your points. And also how they mark you, right? So in your exam, right, if they ask you to draw a graph, what you need to do, you need to draw your axis. You need to label your axis. Okay? They give you a mark for obviously calculating this point. They give you a mark for calculating this point here. You get another mark for the shape of your graph, that it has the curve, and you never just draw a straight line because log graph is a curved graph, right? They give you a mark for the shape. They give you a mark for labeling your graph. This is easy because it's what they gave you in the question, right? It's the graph of y is equal to log 2x. They give you a mark for labeling your axis. 1 mark, 1 mark, 1, 2, 3, 4, shape 5, 6. Okay? Very easy to score marks.
So if you just label your axis and you write that,
You already got 3
you
marks.
got 3 marks.
Just labeling, just drawing your axis and
It's more
labeling it,
enough.
you get 2 marks. Yeah? Even if your graph is wrong, your axis was drawn and it was labeled.
So wait, this section is 8 marks in the final exam. Right?
10.
10 marks. So 8 marks.
Determinants is 8.
Yeah.
Determinants is 8, complex numbers is 12, graphs is 10. Math is being right? Yeah. Trig is 20 and then
25, 25.
math was right, yeah. 8, 12, 10, 20, 25, 25.
So out of the 10 marks, 3 marks we.
Yeah, but you don't know what they're actually
It
testing.
doesn't matter.
But I saw a couple of tests recently that they've been testing the sections 20, like 5 questions, and then they obviously got some question, right? But the total mark for each question is 20 marks. So I don't know whether they're grouping like determinants and complex numbers as one, graphs and trig, because you see there's also trig graphs we're gonna do next. Maybe they also incorporated that, but we'll see when you get to past your papers. But yeah, okay guys, you understand how we did this one, right? I'm gonna do another example with y'all, but you're getting it, right?
Fine, you're trying.
So I think for us it's just getting the hang of the side.
Getting that?
That converting.
The conversion. And just in your head, remember log base answer equals to 8. And then even write it, that's it. So even if they give it to you, you can write it above or below it. Log, which is your base, which is your answer, which is your index. Sure, man.
Well, he's on the mouse.
Did you ever know it big? I think ladies and people just moving around.
Oh, those are the batteries from his phone.
You know there was some old phones that took batteries.
Yeah.
Remember? You buy that to get the batteries in it.
Yeah. Save batteries. I was a bit confused, man, yesterday. You did the graph for the circle. Right. There was ax squared plus ay squared equals to, right?
Yeah.
And that's a circle, and you did the semicircle, the area.
Area.
Not yet. Had
Graph.
the graph for it. I was a little bit confused there.
But
Because check it out. If you
the difference between it and the formula.
yeah, because now if you convert, you know how you were converting it back and you said it's the same thing as when you did the circle. You said y is same thing as y squared, x squared is equal to r squared. The semicircle, it's the same thing if you do the exact same thing. If you make that the subject of the formula.
Yeah, but see over here they're telling you that the value of y is equal to a positive
Positive.
value.
Okay.
And like how this example here they told you y is equal to negative of whatever that is. So you're only basically taking the negative component.
Yeah.
So that's why if in any other situation, if they like how if it was written like these ones, you would have had 3 and minus 3. Even though you square root
Yeah,
it,
for a semicircle, they will always give it to you in that form.
so this
Yeah.
form here would basically be like for a semicircle. You just need to know
Yeah.
whether it's like an upward semicircle or
Yeah.
downward semicircle.
Okay.
I got it, guys? Okay. Now take a set. Okay, this is another example. They tell you x is equal to 4 log 2 into. Okay? How is?
It's divided by 4.
Okay, so you divide by 4 first. You'll say x over 4 is equal to log e to y. Then
E
e to the power x over 4 to y, right? And then e to the power x over 4 all over 2 is equal to y. Now we want to work out our intercepts. So we'll say for your x-intercept, let y equal to 0. So you're going to get e to the power x over 4 all over 2 is equal to 0. This will be e to the power x over 4 is equal to 0. And then now you need to,
yes, logs.
you have to use logs, right? Because that's the only way you can solve for this, right? So log base answer is equal to, when you get it?
Yeah.
Oh, alpha, and then I think it's above your 0, you'll see a E.
Okay.
You can see the color of it. So if it's a reddish symbol, then you have to press alpha to access it. If it's a yellowish one, you press shift to get it. Undefined, right? So this here is undefined. So then you'll say for your y-intercept, let x equals to 0. So you would say e to the power 0 over 4 all over 2 is equal to y, right? 0 over 4 is 0. E to the power 0 would be 1. So y would be equal to half. So your coordinate that you would have is 0 and 1. So if you look at your graph,
Will it be 0 and half?
sorry, right? So if you look at your graph, this is the coordinate you have, right? And if you go to page 136, you'll see the graphs along the y look something like that, right? But now which one do we use? Right? What you need to do, you'll find another point and you'll substitute a value for, in this instance here, you'll substitute a value for x. Now, right? Because if you substitute a value for x, it will give you a value of y. So you would say let y equal to, give me a value. Okay, 1, right? Let y equal to 1. So let x equal to 1. So this would be e to the power 1 over 4 all over 2 equal to y. So what's the value of y? Yeah, are we confused about what I did?
Yeah, just go slightly back there. Sorry, no, Kaya got it, but
Okay, so
so
see, right? Okay, you understand what we did, yeah? Right? Understand?
Yeah.
And you understand this one. Okay, because this here now is 0 and half. But now we're gonna get two graphs, which is the graph that we have to use. So the graph that we would have to use, we'll have to know another point. So we chose a point along the y-axis because if we're using a value along the x-axis, we basically have to use logs to basically work it out, which is like unnecessary. See over here, the difference was we had to use logs to solve for the value of y, which is why we selected a value for x, because it was straightforward. You just plug it into the equation and you can solve for it. So that's why we're using this. That's all. Right?
yeah, I'm trying to.
Which part you're confused?
I'm saying so now to get another value, you said first you said y, you said no, it's x.
No, that was me. I made a mistake.
Yeah, no, I understand. I'm just trying to figure out. So
See this question, right? Based on the type of question it is, right? You have to use logs to solve for your values of y because of the way your exponential form looks. Right? Look at the exponential form. Here, you have to use logs to solve for x. You can select a value for x as well, right? For y over here, sorry. But what's going to happen is you're going to end up using logs to solve it over here. If you select a value for y, you're going to end up using logs to solve it, and then you can do it, but if you're happy with the conversion, you know how to do it, go for it, right? But if you're selecting a value for x, all you need to do is substitute it here and put this in your calculator. Irrespective, you're still going to get a value that's going to give you the graph that you'll need to choose. Okay? Why I'm saying select the values where you don't have to convert it into logs is because it will save you that small mishap and then you're going to end up messing up with your marks. Okay? Is that fine?
Okay, so I'll put that in the calculator.
Press your fraction button. Right? Then you're on the numerator.
Yeah.
Okay. Press Shift E, no, Alpha E, and then press the button that looks like this. Wait, let me see. Okay, so you press this button here. It has X with a block on the top to the right hand side. X with the block in the exponent. Right?
Okay.
Press that, you'll put 1 over 4 and all over 2.
0.642 64.
0.642 is equal to the value of y. Okay? So your other coordinate you have now is 1 and 0.642. So now when you're drawing a graph, well,
Oh, this is
one point is
this is going to be a problem.
half.
The first problem start with the how to use a calculator.
And the other point you know is, let's just say 0.6 is somewhere. 1 is here. So how will the graph look? It will come curved. You're okay with that, right?
That's not big into the calculator. Log E.
Yeah, log E, even if you set ln of 0.
Oh.
Because remember, ln is natural logarithms, it's log of E.
And then that X is 4, so you say times 4.
Guys, do you understand what I did here? So. I don't know. Okay, I'm still gonna end up doing more because I'm right? Okay, so I'm now on page 147, sketching the exponential graphs. So the formula for the exponential graph would be y is equal to k a to the power nx, right? If a is greater than 1 and a and n are positive whole numbers, this is how you would do it. So I can check out here, right?
Yeah.
This idea. Okay, so your example here is y is equal to 3 times 2 to the power 4x. Y is equal to.
So this is like showing us the simpler form of just.
No, this is if they give you the exponential. Remember, they could have gave you this exact same thing as a log, but they didn't. Now, if they gave you exponential, they're basically showing like if your value of a is greater than 1, your graph will have the shape that they have there. Then you see the other one, if it's less than 1 or lies to 0, it goes the other way.
The other one
These
was
are-
logs, this is exponential.
Yeah, but we still convert it into logs. What they're doing now is they're showing you that see this value of a. Yeah, a is this one, right? If that's your value of a, if your value of a is greater than 1, the graph you obtain should look something like that. On the next one, they tell you if your value of a lies between 0 and 1, your graph would look like that, right? In this instance, here, what's your value of a? Sorry, a is value here. What's your value of a
So it
here?
should be also be up like that. No, be up like that.
What's your value of a?
There will be
It's e, right? What is e? Plus alpha e and put it a plus equals to
0.7.
2.7.
right? Which is greater than 1, right? And then if you look at the first example we did, where's the first example? Okay, the first example we did, there was also a positive value, but what was different with that one you will see when we're doing log graphs next. But in terms of shape of your graph, if this is the example, if your a value is greater than 1, that would be the shape of your graph. Okay, this is the general formula for exponential y is equal to k a to the power n x. So if a is greater than 1, that will be the shape of your exponential graph. Okay, and then if a lies between 0 and 1, that will be the shape of the graph. So even by looking at the question when you start it, you would know already how your shape of your graph should be. Looking at this, your value of a is 4, positive 4, which is greater than 1. So you know your graph at the end when you're drawing it should look something like that. Okay, so let's do this example. Okay, so we already got an exponential form. So for your x-intercept, you let y equal to 0. You let y equal to 0 here, you're left with 3 times 4 to the power x. 0 over 3 is 0, equal to 4x. How are you going to get your answer? You're going to say log of 4 times 0 is equal to the value of x. We already know that this is undefined, right? So, for your y-intercept, let x equal to 0. So here you would have said your formula would have been y is equal to 3 times 4 to the power 0. 4 to the power 0 is 1. So your y value is equal to
3. Yeah, you have 3 times 1. Oh,
okay, so your coordinates is now 0 and 3. Okay, so we know from the answer already, I mean from our rules, that your graph is going to look like what? It's going to look like this way, isn't it? That's what I gave you first, isn't it? Yeah. Okay, so But you don't ignore how it looks like. But you need to show more than one point. And how are you going to show the other point? You substitute a value for. Okay, look at where you actually got an answer, right? And carry on like that. That's it, right? Here you saw when we substitute a value for y, you got undefined. So ignore that part, alright? For when we substitute the values for x, we actually got a number for y. So substitute another value for x. Just keep on going like that, right? So let's say x is equal to 1, right? X is equal to 1, you will get y is equal to 3 times 4 to the power 1. This will be 10 by now, it will be 12. So the other coordinate you now have is 1 and 12. So you can say like maybe 1 here, that would be 12. It's a horrible looking graph. But yeah, that's it basically. Right? And then make sure you label your axis and stuff. Right? That's for exponential form if a is greater than 1. Now let's look at if your value of a lies between 0 and 1. So the example is right. That's your value that he gave you. Your value of a is what?
2 over 3.
Value of a is 5. What's your value of k?
5.
What's your value of a? What's your value of n? N. 3. Right? Y is equal to k times a to the power n x. Okay? So let's solve it. Right? We say for your x-intercept, let y equal to 0. It's already in exponential form. So we'll say 0 is equal to 5, 2 over 3 to the power 3 x. Divide by 5, it's going to become 0. Right? So you're going to end up, okay, let me write here. That 0 is equal to 2 over 3 to the power 3 x. So it's going to be log of 2 over 3 times 0 equal to 3x. Log of 0 is what? Undefined, right? So now you know you're creating an x-intercept. Okay? Now the y-intercept, let x equal to 0. So you'll say y is equal to 5 times 2 over 3 to the power 3 times 0. Yes? 3 times 0 is?
1. Oh, 0. 0 and then that's 1.
2 over 3 to the power 0 would be 1 times 5? 5. So one coordinate you got now is?
0 and 5.
Right? Now what do you need to do next?
You get the second.
Get a second point. So how you get your second point? You just choose a value for
X.
X.
1.
So let's say x equal to 1. So you'll say y is equal to 5, 2 over 3 to the power 3 times 1. So 3 times 1 is 2 over 3 to the power 3?
2.
8 over 27 times 5 times 5. 40 over, give me a decimal. 1.48. So now we got 2 points, right? Our point is 1 and 1.48, and our other point is 0 and 5. Okay? Now if we're drawing our graph, let's say 0 and x, 1, 2, 3. Say 5 is there, right? This here is 0 and 5. Your other point is at 1 and 1.48. So your x value is 1. Say 1.48 is somewhere here. That should be your other point. So when you're drawing it now, that should be your graph. And getting it now.
So you don't really need to know whether it's the shape. You can work it out just by substituting.
Yeah. Okay? You okay with that? Okay. Good. 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 You actually do test a lot of log graphs in the test exam.
No, that's not what I want to do.
No, it's not bad. You get it. Practice it or you see you get it. Once you do, and the main thing is just substitution. If you get a 1 point only, substitute another value. And you get the other point and you just try it. But always remember for a log graph, it's a curve. If it cuts the y-axis, it's not cutting the x-axis. Okay?
We got everyone's time yesterday.
For your writing. You watch the science video.
You're doing physics with us, Thursday. You can still do.
Yeah, I do know, but maybe we'll finish off androids.
And what's the plan Thursday? Friday.
Okay.
With the next section.
Because at least with science, I should finish by next week sometime. So I'll have the rest of the 10 and the following week to just do past year papers. Plus with science, we still have like 3 days before you write the paper itself. Or 2 days, we have Wednesday and Thursday. So for science, we can do enough prep past year papers and whatever.
And maths, what's the plans? Finishing.
With maths, graphs, to do today. I still got all the Sine graphs to do and parabola after I finish with log. So see today, tomorrow, maybe Friday. But graphs will finish this week. And then next week will be differentiation, following week will be integration. But I'll try and finish integration before that. Thursday of the next week. Thursday before your write exams. Actually Wednesday before your write exams. So that Thursday, Friday, and then Saturday I'll see also as well. Because you write chemistry on Monday, and then maths on Tuesday, so I won't have any other time to spare.
I put something in there, but I can't speak now. I can't do it both at once. There's no MC. Because I know it's supposed to be MC, but there's no MC.
MC.
Easy, because MC squared. Einstein.
Oh, I removed the M and something I put in memory and the calculator.
Shift 9.
Huh?
Shift 9.
59.
Here all.
AX.
Here all. And then AC.
See, these are not so user friendly. The older ones were user friendly.
Well, there's going to be functions inside. So we need to change it.
Thanks, Jeff.
Also guys, remember in the exam, right? The minimum amount of points you need to work out is 2 points to draw these graphs, right? Please don't go work out on 5 or 6 points to say your graph must be as accurate as possible. I told you how they give you the marks, right? They give you the mark for working out the intercept. They give you a mark for working out the other point. And as long as your shape, even if you drew it exactly like how I drew this horrible looking one over here, you will still get the marks because of your shape of the graph. They're not concerned about how accurate it is to each value. Just get your shape right, your axis, you name the diagram, that one intercept which will come from calculations, and your one other point. Don't worry about working for x is equal to 2, 3, 4, 5, 6, 7, 8, 9, and then join it with the base came again. Yeah, all good. The second, you got.
Yeah. That's
Let's do another example of this. You feel like you're still a bit shaky in it. Let's say y is equal to 3 log e 2x. Okay? Now they gave you in the logarithm form. What you need to do? Divide by 3 and then convert to exponential. So you say y over 3 is equal to log e 2x. Now it looks like in the form of log base answer equals index. It looks like it's general form. So when you convert it to exponential form, what will it become? E is your base to the power y over 3 equal to 2x, and then you divide by the 2. So you'll see e to the power y over 3 is equal to 1 over 2 is equal to x. Right? X intercept, let y equal to 0. So this will be e to the power 0 over 3 all over 2 is equal to the value of x. That will be 1. 0 it will be e to the power which will be half. So I do this example, should I? It's the same thing.
I think you should.
No, the one I didn't. Yeah, I got a point of half.
Yeah.
Wait, just so it's a coincidence.
Yeah.
Yeah,
Oh.
coincidence.
Okay, then, and then if you had to work out your y-intercept, you should know already what it's going to become, right? So, you would say e to the power y over 3 all over 2 is equal to 0, right? You're going to multiply by 2, you're going to get e to the power y over 3 is equal to 0. To solve for y, you're going to have to say log of e times 0, which will be undefined, right? Okay, so when we are using substitutions for y value, we got an answer. So let's continue with the y values. So we'll say that y equal to 1. So this would be e to the power 1 over 3 all over 2 is equal to x. What's the value of x? Somebody working on it?
No? Trying to make sense.
0.69. Your number?
8.
8. Right? That's your value of x. So now your two coordinates you do know is half and 0, and the other coordinate you know is 0.698 and 1. I'll show you exactly how you must draw your graph in your exam. You will draw your axis first. 2 points, right? 1, 2, 3, 4. 1, 2, 3, 4. 1,
Why are you putting so many?
Showing how you should draw it in your exam.
So we must also No,
I
I'm
don't know, if you
serious.
want, if you can go
I'm
3,
serious,
I just had gaps over here, so I just making it there. Okay, 1 point you know is half and 0. Okay, so your value of there. Okay, the other value you know is 1 and 0.698 and 1. So say 0.698 is somewhere here, 1 is there. So that's the other point you know. Okay, so your graph would look something like that. Okay, so you can indicate the point here of 0 and 1, and this here would be 6, 9, 8, 1, and then you say here y is equal to 3 log e 2x. That would be your answer.
Then you 2.5.
Hmm?
0.5.
Sorry, why am I writing 1?
It'll be half of 0. Not 0.
Sorry. Are you understanding it more now?
I'm still trying to figure out how you expect it to be. It's like eating. It's a long process. I'm still trying to figure it out.
How you get to eat?
Yeah, you know when you're punching it in the computer,
Yeah.
the calculator, hey,
Press.
why is it computer?
Press alpha
Yeah.
and then press
Then I'll try this one.
that times 10 to the power x in the bottom.
Yeah, okay.
There's e.
And then the exponent, you press that one.
No. First put 1.
1.
Yeah.
Yeah.
Also,
Just like I say,
alpha. Yeah.
Mm-hmm.
Then you put the 6 here. 1. Right. Then 3. Right. And then put answer. 3 divided by 2. That's how I do it. But you can do this an easier way. But that's simple. You do the one big thing that comes.
Actually, what you guys set up?
So
okay. I'm gonna do one
24.
more example, and then you should be okay with it. First, first 10. Why does 10 go so fast?
Because you're so exciting.
Okay, let's do one more example then. I'll give you a time to check out everything one time. So you got a logarithm form. Okay, you're gonna basically answer this way. I'm just gonna write down what you'll tell you. Okay, what you do first?
Remove the 3 across.
Right?
So 4x. 4x. 4x equals your 2 okay, y over 3.
I thought start with the base first. I thought you were taking
I'm also
that thing
Yeah,
the
but
base.
you can
and
do
you
it this
do
way.
it anyway. Okay.
confusing us. Can we just start with the webinar?
Then normally the way we were saying that we would say log of base, your answer which is y over 3, and your index would be 4x. Right? Now we got it in exponential form. But now you need to multiply by the 3 obviously, right? This will be 3 times 2 to the power 4x is equal to y. Okay? Yes? You lost? I multiplied the 3.
No, man, it's
No,
a
you
y.
mix it
No,
up.
it's
Right?
yeah,
It's
no.
2y over 3.
Yeah,
Equals
it's
to
4.
You mix it up.
Yeah, so
Well,
so it's with a power
Yeah.
that's a 4.
I think you're paying attention to it.
Trevor is all Trevor's fault. Trevor started
I
off.
started the whole thing. I lost my own motion and everything after that. Right? Log base. This is your answer. Base answer equals index. Yeah. Right. Right. Happy with ourselves for that? Okay. Now you divide by 4. So it will be 2 to the power 3 divided by 4 equal to, right, then what you do?
So let y
Y
equal 0.
or integer.
Right? So it will be 2 to the power 0 over 3 all over 4 is equal to x. 0 over 3 is
0.
2 to the power 0 is
1.
1. So it will be 1 over 4 is equal to the value of x. Your y-intercept, you left. Right? So what's going to happen? It's going to become undefined, right? You know that, right? So this would be, must I show you or can I just say undefined?
Show us.
2y over 3 all over 4 is equal to 0. Then you're going to end up with 2y over 3 is equal to 0. Because you're going to multiply the 4 across. Right? It's going to be 0. Now to solve for that, you would have said log 2 of 0 is equal to y over 3. But if you put log 2 with 0 in your calculator, this is going to become,
Do you have to show that in your paper?
yeah.
You have to.
I don't think you have to show the whole working out. I think you can just say y-intercept let x equal to 0 undefined. Because you know that if it cuts either your x or your y, it's not going to cut the other axis. The value that you substitute for 0 is going to be undefined. Okay? Then we only have 1 point. What you'll do next?
Then another point.
And for which axis you're substituting? Substitute for the y, right? Because we actually got our answer in terms of x. So you would say let y equal to 1. So this will now be 2 to the power 1 over 3 all over 4 is equal to x. What's the value of x? Four point three.
No, 0, 0.3.
0.3. 0.3. 1 point. Okay, I'm just leaving it like that. Okay, so now we got 2 points. Our 2 points is a quarter and 0, and your other point is 0.315 and
0.
1.
I never expected that from you. Right? Remember, quarter is 0.25. Okay? So, let's plot it. If you did this in your paper, what you already got? 2 marks, right? Just by showing your axis and obviously drawing it properly, right? So, 1 point we have is 0 and 0.25 and 0. So this just say 0.25 is there. Okay? The next point you have is 0.315 and 1. So let's say it's here. Let's say it's there. So that would be your other point. So when you're drawing a graph, it will look like again, and here you would say y is equal to 3 log 2. That's your answer. Fine? You understand log graphs now? Ah, you'll have to. I know you'll understand it.
You're missing 2 marks there.
Oh, and the points. Yeah. Yeah.
Minus 2.
So they won't give us straight lines or hyperbolas and things. They'll end up
They
giving us
sometimes may give you all, yeah. No, not all.
Yeah.
Maybe about 3 of the graphs
Yeah.
to draw.
Okay.
You see, it's a past papers there.
But each one will have the same number of marks.
No, it's dependent on how difficult it is to draw.
No, what I mean is basically, let's say there's 3 crops, and you said it's 135 watts each.
Yeah. Yeah, it's
It's good, yeah.
yeah, it's not bad. We'll see when we do classical visualization. Okay, so that was your other type of graph, which is your logarithm graph or exponential graphs. Anybody have a problem? Are we okay? Okay,
Yeah.
you're okay, right? Now take it on. Okay, sir.
That's it.
Now we on trigonometric graphs. So this would be point number 7. What is? Logs was 6. This is 7.
Yeah.
Right? Oh, no, easy. Now your trigonometric graphs, yeah, page 150, right? Your trigonometric graphs is broken up into 6 graphs, right? Sine, cos, tan, sec, cosec, cot. Okay, so let's focus on sine graphs, right? So let's say 7.
Can I just ask you a question? Where does parabola come in?
And it was then
Oh,
it's after the.
Oh.
And there's also one more, it's called a cubic function, but after you learn about differentiation, you'll learn in differentiation how to solve for the cubic function, right? Okay, so page 150, right? The sine graph. So if you have y is equal to sine x, right? For your y-intercept, you would let x equal to 0, right? So you just said y is equal to sine of 0. So what is the value of y?
0.
Y is equal to 0. For your x-intercept, you let y equal to 0. So you have said 0 is equal to sine of x, right? And then x would have been equal to shift sine 0, which would be 0. Okay, these are our coordinates, right? Now the thing with sine graphs, put sine of 180 in your calculator,
0,
put sine of 360 in your calculator,
0,
put sine of negative 180
0.
and negative 360.
0.
I knew. You can put it. So, 4 is sine graph, right? So y is equal to sine of x. X is equal to, it's call it 0 points, right? So it's equal to values of negative 360 degrees, negative 180 degrees, 0 degrees, 180 degrees, 360 degrees. Right? And if you look at page 150, they tell you about that circle, and they tell you each time r reaches the points marked by the cross, sine of the angle is equal to 0. Right? And in general, a y equal to sine x graph would look something like this. Right? So when you join, your sine graph will start from 0, right? It will move towards your y-axis this here will move. Sorry, it's not accurate, right? But in general, this is what your sine graph looks like, which is why you get certain values of certain things, right? If this was accurate, if you put sine of 90, you get y is equal to 1, right? Sine of 90 is 1. This is what your sine graph looks like, and I'm going to use this to explain other terms I'm going to do later on. Now, these 0 points are, it will always be like constants, right? Okay? So when you're doing your calculations, and you're going to see when we do an example about how these shifts, you need to remember that x is equal to 0 at negative 360, negative 180, 0, 180, and 360 for sine graphs. Cos will also have its own value, and tan will also have its own value. So this is in general that. Now, remember every single thing has a general formula. So I want you to look at page 153, right? Page 153 towards the center, they tell you consider y is equal to a sine bx plus c plus d. So can you all see that? On page 153. Then towards the center.
Sorry,
Yeah.
before you move on. So generally what you're saying there on that graph is showing us that when you calculated the y equal to sine x, on those points 360, 180, 0, 180, and 360, on the x-axis it will always be 0.
Yeah.
But the y points have a value,
Of, well,
but it's saying 0. So where it's curving there, that's a value, right?
like here and here.
Yeah,
and here.
there.
Yeah. So see, like from 0, this here is supposed to be 90 degrees, right? So if you put any value for sine of any of these degrees between 1 and 89, you're gonna get a value that's 0 points something until less than 0.1. I mean less than 1, right? And then, okay, let me write this part here and then I'm going to explain to you how it goes. But in general, if y is equal to sine of x, this is how your graph looks. Okay? The graph, you start at 0, on your right hand side you move up towards 1, at 180 you need to come back and cut it at 0, right? Okay, I'm explaining it. Sorry, let me do this part, right? So, this is your general formula for sine. Y is equal to a sine bx, bx plus c plus d. Now, each letter does something to that sine. Remember I told you that all you're basically doing over here is either you will pull this graph, or you will compress it, or you will shift it up or shift it down, right? That's basically what we're going to do, right? So, your first point is A is equal to the amplitude of a graph. Now, what is the amplitude of the graph? Amplitude is the amount by which the graph of the function travels above and below its midpoint. Okay? So, it's basically the midpoint of this graph, of this specific one, is your x-axis. You'll agree? Yeah. Right? So, the amplitude of this graph will be the amount that the the function travels from its midpoint to above or below its midpoint, right? Okay. So, this here is your amplitude of the graph, right? A value is equal to your amplitude. If you look at this, what's your value of A?
1.
It will be 1. Because remember, it will be y is equal to A sine. We don't have a value of, or well, actually our B value is 1 plus, there's no value of C, there's no value of D. This is 1 times sine. Get it there? 1 times sine, 1 times x plus 0 plus 0. Okay, so now your amplitude is basically 1. Now amplitude will give you from the midpoint how high and how low your graph is going. Okay, next thing is the period of the graph. So period is basically 360 over the value of b, right? And period is basically the time taken for the graph to make one wave. And one wave would look in a sine graph something like that. Right? So the period is the time taken for it to make one wave. Get it, right? So your period in this graph here, your value of b is what? 1. So your period would be?
1.
How?
360.
360 over b. b is 1. So your period will be 360. So if you look at the time taken for this to make one full wave, that is your period. Understand? Get it? Okay. C determines the displacement of the graph to the left or the right. Okay? So the value of C will determine whether the graph moves, this whole graph here will shift to the left or whether it will shift to the right. Period will basically determine whether the graph is now squashed. Okay? Because if your period was 180, remember the time that it would take to make one full wave will now be 180 degrees. So it will look like that. Right? The same line here will now fill up this portion here. You get it? Okay. So the value of C and how do we calculate how much it displaces? You would say minus C over the value of B. Right? That's how you would calculate how much it will shift. You will see it in an example, okay? So you would say minus, so if you've got a value for C, you would take that value and divide it by B.
And your negative and positive determine left or right. Which way you're going to shift to. Yeah.
You got minus here already.
Yeah, that's the formula. Right? You will substitute it as minus. Yeah, and negative or positive will determine left or right. Okay, whether you would move, if it's a negative value you obtain, you move left. You will see it when I'm doing my turning points. That value you obtain there, you basically will either add or subtract it to here. Okay, you'll see it in the example. I just need to show you this so you'll know what I'm saying, right? And lastly, the value of D will determine the displacement of the graph along your y-axis. So, up or down. Okay, so D
So what's the difference between that and amplitude? The displacement up and down?
amplitude is the distance from your midpoint to your, well, above or below. Okay? Now what will happen if your displacement on that was 1? Right? This entire portion from this line to this line will shift 1 unit up. So now your middle line will be at 1. And your amplitude will, it will still be, amplitude is still 1, but this value will be 2. And this bottom value will start at 0. Understand?
So the D moves the entire
The whole thing up or down. Your C over B moves it left or right. Your period either squashes it or pulls it out. Okay? So this is why you know your general graph, what it will look like. You will always remember these points because you're going to see it in calculation. Okay? That's the general formula of the graph. This is a y is equal to sine x graph. Okay? If we understand this here in the few examples I do, cos and tan will be no, actually all will be no problem, right? Because all of them are written with the same general formula, but you just swap sine for cos for tan, you know, each thing. But all of them have an amplitude, a period, C value for displacement and a D value for displacement up or down. Okay? You want to take this down? Yes. Take it down? Okay. You know all the theory looks better when you do an example, right? So.
Yes.
you took it contrary.
You'll be having method engineering and then go computer itself. No, have you been?
I don't know. I've done the avions to see alphabet too.
Yes, we think it was a good idea.
That'd be a very good idea.
So, Fabian, and your plan for the next 2 weeks going forward for maths and science. You just send us and tell us what your plan really when you're doing past your papers, what sections and stuff here.
Yeah, but it's not like set plan. It all depends on how much
We can
time.
discuss it in the video.
Yeah, you can go back and because you love watching and picking on the things I say.
I'll tell you why. So, like, I think it'll be okay then. We know, like, for me,
You'll be calm.
no, I know exactly which lessons to come for and which ones not to come for.
Yeah.
No, because I'm
No, but
working.
you're
No, no,
Yeah,
no.
yeah.
But
Yeah.
yeah, you did
Yeah.
explain it to us.
Yeah, no, okay, I'll
It's
send it to you.
self-portrait,
Yeah.
But yeah, you can.
If you can, like, I know it's difficult. It
Right.
depends on what you do in the.
Yeah.
Things like, you know, you do.
You're laughing at it, huh?
Take your baby.
I'm going out with bomb work. And this is only M4.
Yeah.
I'm very sick leave these days. Sick leave, work from home. I mean, it's really nice.
Let's see. That's the example.
And also school stuff, but more related to the soil here came back. Doesn't get more difficult like the questions yet, no? The graphs?
Not really.
Should be the same, eh?
Because the graphs are a very small section of your test.
Yeah. Hey, limits, integration, differentiation.
Those ones should come for every lesson.
That's what I want you to put it on the board.
Oh.
Yeah.
See, if I finish
See, like for
one
me,
day,
if you didn't pass the papers, I'm not going to own here.
You'd rather watch it,
I'd rather watch it
yeah,
at
yeah.
home and.
But see, if I finish graphs on Thursday,
Yeah.
I finish graph tomorrow, right?
Yeah.
But I don't think I would finish. I finish on Friday, right?
I think if you do that, I think it's if you're starting a brand new section, it's going to mess everyone up
But start on Monday.
for Saturday because everyone's going to be.
Yeah, we studying.
Yeah. Mm.
I'll start differentiation on Monday,
Mm.
and I'm gonna be moving with differentiation all week.
Yeah, okay.
And I doubt I'm gonna do that quickly because
It's a big
it's not a
section.
difficult section. So
So by the end of next week, you should finish off differentiation.
that's my goal.
Yeah, okay.
I want to finish differentiation by next week.
Alright, okay.
Now you can remember asking to throw in somewhere with the revision for your maths test that you're gonna do. Right?
Yes, next week.
Oh.
And then for physics, you said you by tomorrow you should be. Physics, yeah. Tomorrow you said you. Today you.
Today, tomorrow I should finish hydraulics.
And you said you wanted to start a new section on Friday.
Yeah. Carry on.
If you start a new section on Monday, I'm just saying. You put you out of sync.
No, it's fine.
We won't finish.
No, we will finish. For science, we are.
Because we also
No,
have
I-
to cross practice.
I'm just saying, sometimes you start a new section, you know, on
You all got it, guys? Don't worry, that's not I'm not gonna take out now, right? I'm not gonna take out that set now, we use the set, but you got the set.
you should start a new section on Monday. It's okay.
Don't have graphics.
Hmm?
Just don't have say graph in it tonight.
You know, it's just on Friday.
Technically, section.
Mine is not going to be there. Yeah, I think, Jeff, I think Monday and Tuesday you need to start new sections for physics and maths. You know, our minds are not going to be there. Everyone's going to be stressed. Something just to think about, right?
Yeah.
But I think we caught up quite a bit from where we were.
No, for sure.
Yeah. You did trig with us and you did graphs.
So we just got 2 more.
Yeah. Yeah, we'll make it. And then this hopefully maybe by end of the year we get our maths papers marked.
Yeah, you do this line off.
I'll speak to, but no, don't stress, I'll speak to Lloyd. I'll ask Lloyd to mark papers. Not this.
You better hope I don't mark your papers.
But I'll ask you a question. How long does it? Doesn't take long to mark a
Yeah, I
paper.
was teaching the whole day on Monday and the whole day on
No, not for you. Rowan could have backed the thing off. Doesn't take long, bruh. I think.
Guys, okay, I'll do that same graph here, right?
Oh.
Fair. I'm also going to be referring to, because remember I told you it's the same graph, up, down, left, right, that sort of thing, okay? So, let's do an example. Checking this out now, right?
Just a quick one. No, you can take it out. Yeah, you can take it out. So if D is negative, the graph will shift
Down. Yeah.
D is positive, it shifts up. Right.
Okay? Oh, you'll get that, right? If the value that you obtain, negative C over B, is positive, your graph will shift to the right. Okay? If your value of negative C over B comes out as a negative value, your graph will shift to the left. If your value of D is positive, it will shift up. If it's negative, it will shift down. Okay? So, which example was it? So, y is equal to 3 sine 2x. Okay? So, let's work it out. Okay? So, for your x-intercept, you let y equal to 0. So you say 0 is equal to 3 sine 2x. Yes?
Yes.
Yeah, right.
Okay. So you would divide by 3 over here, you're going to end up with 0 is equal to sine of 2x. And then shift sign of 0 would be 0 is equal to 2x. Right?
No, it's a special line. Compound line. I'm joking, get it.
No, so your reference angle in this whole situation is going to be zero degrees.
No sign of 0.
Okay, now let me not use reference angle, you're going to mix it up with the other one, right? Okay. What I told you your 0 points for this was?
180 minus 360, 180 minus 180, 0, 180 and 360.
Right? So, you're gonna say 2x is equal to negative 360, right? Because your 0 points for it. You're gonna substitute your 0 points for all these values of 0 here when you're solving for x.
So you'll have 1, 2, you'll have
5,
4.
4. Because remember when y is equal to 0, right? You're gonna come out with 5 points where x will 5 values of x where y will be equal to 0.
Yeah.
Okay? Okay. So if you have this, you have 2x equal to negative 180. You'll have 2x equal to 0, 2x equal to 180, and 2x equal to
6.
You understand this?
Yeah.
Right? These are your 0 points. Okay? So x will be equal to negative
180,
x would be equal to
90,
negative 90, x would be equal to 0, x would be equal to 90, x would be equal to. Okay, so now we got our 0 points. Let's examine some other information, right? So your amplitude is what?
3.
3. So that means that this graph from its center line is going to go up and down 3 units. Okay? Then the period of this graph is equal to 360 divided by b, which is equal to 360 divided by 2. Your value of b is 2. Okay? So this is 180 degrees. Right? There's no displacement on the left or right of the graph. There's no displacement up or down on the graph. Okay? So now let's draw the graph. Your center point of this graph will be where?
0.
0, right? The x-axis, because there's no displacement up or down. Okay? So this would be 0, this would be minus 90, this would be
Minus 180.
this would be 90,
180.
180. Okay? Your amplitude,
Would be 3.
this would be 3, this would be
Minus 3.
minus 3. So far you understand what I'm saying. Okay? Now your sine graph would start from 0 and 0, right? In this instance here, because it never shifted to the right, it never shifted to the left. So when you're drawing it, you would go up. Remember at 90 you need to come to 0. You would go down. On this end here, you would go the opposite way. And that would be your graph.
So what was the period for?
From here to here is how much?
180.
180. Time taken to complete one wave.
Yeah, right.
So you need to see that
Yeah.
it actually works out like that. Okay? Do you understand?
Yeah.
Anybody confused? Fine. Every-
But
we splashed it.
the 0 points would have been the same because the 0 points told you where you're going to start from, right? Your range basically. That would be the same as the. I'm sorry, I'm confused with 0 points in the period.
Yeah, but
Yes.
No, the 0 points have changed.
just
Hmm?
there.
The
Your 0 points have changed.
changed.
But remember I told you your period, right? It either squashes or it pulls your graph.
Yeah.
Okay? Look at how this graph is. Here its period was, in this instance would have been 360 degrees, right? So it's spread, if this was drawn accurately, it's spread out nicely, right? Now when you increase the period to, or sorry, decrease your period to 180 degrees, it obviously squashed the graph. Can you see that?
So it's only for the one side.
Both
Both
sides.
sides.
So now come it's not 360 then.
Where?
It's normal
If you
360.
wait to
huh?
360,
See, it's time
180.
taken to complete one wave.
Yeah, one wave is just that. It's not the full. Up and
So
down.
this
Yeah.
here is one wave,
Okay.
this
right.
is two waves.
Yeah.
Okay?
Right.
Just there. You just dropped the sign there. Or did you do anything?
Even if you shift sign 0, you can see. Okay. So you came to a point where you need to have your 0 points now, because this here is basically 0 degrees. So you know now when you reach 0 degrees, you have to introduce all your 0 points. Understand? Let me do the next one once again, right? Where's the next one? Okay. The next, so this was one example. This is another example. Okay. Next example is
Plus 3.
you just plus 3, right? So you said y is equal to 3 sine 2x plus 3. Okay? What is the plus 3?
D.
D, right? C value will be found in the bracket there. You would see it in a bracket. Okay?
Yeah.
This is your D value. What does D mean? shift it up and down. You don't need to redo this entire calculation, right? Your 0 points will still be the same.
But we
because
like,
your 0
but
points
we like to redo it again.
but I don't want to redo it again.
Okay, right.
Right? Your 0 points would only be affected by your period and your phase shift to the left or right. That's the reason why I'm saying I want to show you something, right? So, all you need to basically do, the only difference with these two is going to be this entire portion moving 3 units up, right? So, when you're now drawing this graph, your middle point of this graph is going to be where?
-3.
Plus 3.
It shifted 3 units up.
Yeah,
3
But
over
your middle point of this graph is what, guys?
Oh, sorry.
0.
Which is 0.
Yeah.
Now, if it's shifting 3 units up, your middle line is going to be where?
3.
3, right? So, 1, 2, 3.
But then how does your x point stay 0? Stay the same.
It doesn't say the same.
Yeah,
It moves up by 3.
Yeah, it moves up.
Huh?
Okay, no.
No, see what you're talking about is, see when you came to this part here,
Right, that's not like it.
when you came here and you said plus 3, what you going to do with the 3 here?
Add it on to the, so it becomes,
Take it across.
so 2x won't be, it'll actually be 3.
Huh?
The plus 3. Okay,
That's why, I think we should have started off with the equation and done the whole thing. Like,
Wait,
how
I need to show you what I want to show you.
Okay, yeah.
Okay, the reason why it doesn't change is because when you take this 3 across, it becomes negative 3, right? You're going to divide by 3, it's going to come negative 1,
minus 1.
right? Shift sign of negative 1 is what? Negative 1
Minus 90.
minus 90. When you put it into your calculations and you carry on going further, you're going to see that with the change in point, it's not going to come out to the same turning points. I'll do the calculation if you understand that, right?
Yeah.
But in terms of the shift, I told you that it moved 3 units up.
Yeah.
So the center point, which was at 0, is now 3. And now, your highest point in your amplitude would be what?
6.
And the lowest point in your amplitude would be
0.
0. Right?
6? Oh, because you're moving 3.
So if your amplitude is from your midpoint
Okay.
above and midpoint below. Okay? So this would be
Minus 90.
so your graph would now look yes.
No, that's not the
Structure.
instead of the
Well, USB start from 0.
No man, you don't start, you start from 3, it's just that I'm drawing it too close.
Start from the y-axis 0, like how you normally do it.
No. That's it.
Sorry, yeah.
That's it.
Right.
No, it's
Start, do it like how you normally do it.
Well, 180 needs
Start
to
from
be
the
3.
center, go this way, and start from the center, go that
180
way.
needs to end at 3. Yours is going
Yeah, the one on this side is
It's going to
it's supposed to end at 180. Not touch 180.
So it's sending.
Oh, this guy, yeah, I'm not too far, sorry.
Yeah.
How you normally do it.
Hey, the teacher's being taught. Kaya is. Yeah, I'm gonna fail my test. I can just see you.
I should have just done that at the start. Two of things.
How you normally do it.
Right. Now you see this entire graph that looks exactly like this, just shifts 3 units up. That's what this is for. Shifting it 3 units up.
If it was minus.
Minus.
If it was minus, it would have moved 3 units down. Your highest amplitude would have been 0, your middle line would have been at minus 3, and your lowest amplitude would have been minus 6. Okay? Take it down.
And then if we have to substitute now, like you said, we'll solve obviously for those 3 points, right? You've got minus 360, minus 180, 0, 180, 360. Right? Then it'll mean minus 3 sine 2x's minus 1 inverse sine of minus 1.
Minus
1 is minus 90.
So, when you're working it out from there,
That will be 2x.
because sometimes they do when they're working out your 0 points, they don't take into account the d value at all. They only take into account sine bx plus c.
Okay.
Because remember, d is just to shift it up and down.
Yeah.
That's all it is. Shouldn't affect the calculation in any way. All you're doing is shifting it up or down.
Okay. So let's check out the
All the graphs are the same. Not because of 10.
So see, for this part when you're using 0 points,
Yeah.
right? Only consider sine. Well, you can take your amplitude, but if you divide it, it's going to become 0. Sine of bx plus c
Yeah.
when you're working on 0 points. And with the other ones, you just with the d value and stuff, you use it to shift up or shift down.
So I'm trying to work out the domain, right? The range of the domain basically, right? So you first have to solve for x to the 4. As you said, where it's going to cut at minus 180, 90, 0. Right?
Yeah, but
So
use
you're solving for
only use that portion of bx plus c when you're using 0 points. The other one you would have been for your intercept, the entire equation.
so you just say sine 2x is equal to minus 660,
Yeah.
sine 2x is equal to. You don't worry about the rest of
The rest is used to either move the graph.
Yeah, it's a very important one because we all might mix it up, huh? We'll all try and solve for. Because we get confused with trig how we solve that, as you mentioned earlier now. That makes
Yeah, in
sense why you
terms
said
of,
that.
yeah, that's why I said
you
living
yeah.
under call it the reference angle and the quadrants and stuff.
Uh,
It's gonna confuse you. That's a shame.
what time Abby wants to?
I still got look at science to do. Can we do one more example for sine? Then tomorrow we can do cos 10. Yeah, graphs, I'm gonna get a video. Tomorrow we got shorter time, we got 1.5 hours. Because tomorrow
It's
is
a normal, it's normal.
Yeah.
So cos is similar to the sine graph, I guess, and 10 is just 40.
So all these follow the same principles. You're just substituting x, substituting y, and you just need to know the shapes.
Here you would have actually got an intercept for this one. Because remember you have said for y-intercept let x equal to 0.
Yeah.
Sine of
0 is
0
0, but
times
3.
3, but then you would have ended up with y equal to 3.
3, yeah.
So it would have
There's
cut
3,
it there at 0
3.
and 3. That will give you your middle line.
Yeah. Yeah. But we didn't have to show that because we know the shape.
And we know the amplitude. No, the amplitude basically gives you the cost.
So if you just draw the graph without using like a follow-up question, you don't need to recalculate it, just draw the graph.
You will see, like, probably if they gave you this in the test, right, or in the exam, they would have made that like maybe 5 marks, right? The first one, y is equal to 3 sine 2x, right? And then they would have told you, draw the graph of y is equal to 3 sine 2x plus 3. What you'd have seen the marks would be 2. And now you're wondering to yourself, why is it 2? Take a whole different way. All they want to see is that you shifted it up. That's all. Up or down, that's all. Okay?
Parabolas after this. And what's the last one you said? Quadratics. Cubic. Yeah.
That's what you
What
can
shape
use
is that?
differentiation to do.
What shape is that? Like all over the place.
Come out. Parabola comes out like this.
Yeah.
The cubic function also comes out like this. No, come out. You end up with like 2 parabolas.
With a sine graph.
No, but it comes out like one coming like a U, and then one comes out next to it like that.
Yeah.
Because you end up with 3 values for x.
Like something like this one. Yeah.
No. I'll show you. Even if you understand differentiation, I'll be so happy. I know you're passing this. Integration is actually shorter. Very much really it's like the opposite of differentiation.
I'm doing cos without x.
I'll do one more example for this.
I'm finishing off side.
Shift, yeah, and then tomorrow I'll do cos tan. I'll try and finish all the tangents. I'll have to finish cos and tan tomorrow. Maybe. But if you look at the cosec and sec graphs, there's no actual calculation that you have to perform. It's basically 1 over your other values. So you have to learn the shape of the graph. So if they ask you to draw it, you will know how to draw it.
Now, people, next week it's up to graphs or it's including graph differentiation?
Graphs.
Up to graphs, that's it.
Everyone get?
Almost.
Okay. You can even draw these graphs by just looking at the formula. Not even working on those points. Because you basically, see, that's a standard one. Right? In terms of looking at this formula, your amplitude is now 3. So instead of 1, your graph moves higher and lower by 3. Right?
2x
And then-
compresses.
To 2, yeah, 2 will basically,
Compresses.
your period will now make it smaller. So for one wave, it will compress. And then the last one will shift it 3 units up. So even looking at your phase shift in the next one. Okay, so phase shift is, if you look at y is equal to 3 sine 2x plus 10. Right? On page 152. Yeah? You're going to work out the phase shift, you'll say minus 10 over 2, which is minus 5 degrees.
10 over 2. Okay, nice. Yeah.
Minus 10 over 2, which is minus 5 degrees. So all those values would shift 5 degrees to the left. Okay?
This is the thing, man. This is theoretical stuff, man. That's fiction.
You can work for this.
No, I'm saying
You can synchronize the.
So you see all these turning points which will now be minus 185, minus 95, minus 5, 85, and
Oh, I see.
minus 175. So using one standard diagram. You got it? You're done? Oh, fine. Don't tell me.
So what if you just punch in the figures from your formula
And we're using sine.
and for your graph without doing any calculations?
You'll have to look at them. Okay, see, because they want you to sketch these graphs, I think it's dependent on how much marks they're asking you for. You can look at it, okay, question is 7 marks, obviously they want you to do calculation, then draw the graph. If it's 3 marks or something, just draw the graph, you'll know it. Okay, I'll tell you how to do it, alright? So say you have y is equal to 3 sine 2x plus 10 degrees. Okay? So you'll say your x-intercept, let y equal to 0. So this will be 0 is equal to 3 sine of 2x plus 10. You divide by 3, you're going to end up with 0 is equal to sine 2x plus 10. So now we're going to look at our 0 points, right? So now you're going to end up with 2x plus 10 equal to negative 360, right? Then you're going to end up with 2x plus 10 equal to negative 180. Then you're going to get 2x plus 10 equal to 0. 2x plus 10 equal to 180 plus 10 degrees is equal to 360. Right? And I tell me, okay.
No, he's asking something about the. Because he works it out, the plus 3, and then it didn't come to the. Anyway,
For the turning points,
yeah.
you don't consider that plus 3, that phase shift up and down when you're working on turning points. You just consider by basically sign of whatever's in these brackets.
Yeah.
I
Okay?
think that's the
Because
key.
even amplitude won't affect it, because you see when you come here, you're gonna obviously let it equal to 0 for us to actually start working 0 points, right?
Yeah.
Your amplitude divided by it is gonna become 0. So you don't consider the amplitude and you don't consider the value for d, the phase shift up and down. You're considering the values that make sine 0. Understand? Okay? Sine of whatever should give you 0. Okay. So here you're going to end up with, you take your 10 across, negative 3, negative 370 divided by 2. Negative 185, right? Here you're going to end up with
190 minus 190. 95. Five. 175.
right? One. Yeah, yeah.
That's the. We want to find the t. Oh, D basically the top.
Yeah, don't think it's right. Okay, so we got our points at where x would be equal to, or y would be equal to 0. Yeah, y would be equal to 0 for these values of x, our 0 points. Right? The amplitude of your graph is the period of the graph is 360 degrees over 2, which is 180 degrees. Any other information we need to write? No. Right? We already included our phase shift here. Right? So when you're drawing it now, your center point of this graph would be 0. Right? It never shifts up or down.
Sorry,
Yeah.
what did you say? We don't do anything with the 10, the C.
We included it here. You see this part here where we said your phase shift is equal to negative C over B. Right? This in this question here would have been 10, negative 10 over 2, which is negative 5 degrees. Right? So basically it means that it's moving, this entire graph is going to move 5 degrees to your left. Okay? So what ended up happening was, you see the turning points we had in our last graph, in the one below, above this. But actually the first one, y is equal to 3 sine 2x. Right? Those points we had negative 180, negative 90, 0, 90, 180. Right? All those points moves 5 degrees to your left.
Oh, so you don't actually have to work it out.
We basically did it here.
Because
You
it's
see?
always going to be in the bracket.
Yes.
So it's always going to be worked out already.
Yeah, so we're always going to include it here.
Oh, okay.
But if you, like say, like how that other question was, where we had the start, y is equal to 3 sine 2x, right? You did your whole calculation, it was a 5-mark question. The next question, they said show the graph of y is equal to 3 sine 2x plus 10. And you only see it for 2 marks. You don't need to redo this entire calculation here. Wherever your 0 points are, work out the phase shift and then add or subtract it from there.
Yeah, what?
The phase
And
shift is
then you
that.
just change your
The phase shift
to
is this.
5.
Yeah, so you can even see it in these calculations.
Okay.
Right? That's fine.
So you'll work out that one and then you just add it to whatever or subtract.
This one you would have worked out in that first question. Y is equal to 3 into sine 2x. Okay? This, yeah, that's what I was saying before, like how you can look at a formula, identify your information, and apply it to the original formula. Okay, what I'm saying? Okay, so from this one here, if you're looking at that graph, right, your amplitude will now be 3. So this here is 3, this here is right? Your 0 points are minus 185, minus 95, minus 5, 85, 175. Good. Okay. Now you will just basically need to draw your okay. That's your graph. And one is different from that, and that first example you did where we had y is equal to 3 sine 2x,
Shift to the left.
is that all your 0 points just shifted 5 degrees to your left. I get that.
Yeah.
Okay? What's different from the first example and the second example was that entire graph shifted 3 units up. Okay? So if they add the whole thing inclusive of the plus 3,
Yeah.
you would shift like this, and all you would do is go 3 units up. So your center line would be at 3, your amplitude is still 3, so your highest point would be 6. Do I get that?
Do we have to show the intercept on the y-axis? Do you have to calculate and put it on the graph, or it's fine like it?
You talking about this one, yeah?
Yeah.
You can, but not really.
No,
You don't have to. It's not a critical point. Your critical points over here are the 0 points, right? And then you know obviously you'll either go up or down between the 0 points. Yeah. If you want to be accurate, you can change. It's not difficult. All you would have done was you would have said let's x equals to 0. So this would have been
3 sine 10.
0 sine of 10, and then you would have got a value, multiplied it by 3, and you would have got that coordinate. Okay?
But it's not
It's not
required.
No,
required.
you don't have to, because you're gonna always have that shape for a sine graph.
But would they potentially ask you that?
No,
They wouldn't ask you.
no,
They don't, sorry.
not really.
Okay, just look at it, see, if we had a value for D and we were calculating these points, we would not include it in the calculation, am I right?
For these
Yeah, for the
0 points.
So you remove it from the calculation.
Yeah, in terms of your 0 points.
Yeah.
You'll only take into consideration this.
Okay.
Your 0 points would be when sine of whatever is equal to 0.
A, B, and C.
Yeah.
Yeah.
But it's not even, you don't have to include A, because A will get
Not to
divided by
say, yeah,
0.
but the D part you take out of it.
Yeah.
Okay.
Can I understand it?
Okay.
Okay. Everybody's okay? Okay, so we're gonna stop here for today. Please, when you go home, go over cost, because you'll see cost is the exact same method as this. The only difference is it has different 0 points. Okay? That's the only difference. Everything else, it still has the amplitude. You still work out the period the same. You still work out your relationships to the left or right. You still work out your displacement up or down. And with the cost graph, it starts at 1. It doesn't start at 0. That's the only difference. You see with the sine graph, we start at 0 and then move. That's the difference. Okay, guys. So we're good. We're okay. Any questions? Chamba, I know you're gonna ask something. Ask it.
I don't know, you should change this.
I shortchanged you. How?
You know when you was doing that example where you had y equal to 3x 3 sine 2x plus 3, the one that L was asking about. Yeah, because that's where I got lost when I was doing my own calculation.
I will tell you
yes,
not
never
to
told us
include
not
the
to
up or
include.
down.
Yes.
I'll follow you.
No problem. Okay. We all make mistakes.
Can't worry about the smaller things in life when you try to pull yourself outside something.